Welcome pre-cal students to the homework help video, page 298, numbers 49 through 97. Let's go ahead and get started with the problems. Numbers 49 through 53, the directions say list all possible rational zeros of the function. So here we go. Step 1 says to make sure you've written the function in standard form, and we've done that. Next, you write out all the factors of your lead coefficient. Your lead coefficient is 1, and all the factors of 1 would be 1 times 1, and of course we do not need to write the 1 twice. Then you write out all of the factors of your constant term, which is a 1, and the factors of 1 would be 1 times 1, and you only need to write the 1 once. Then you take all your numbers over here and you put them on top of all the numbers over here. So we have a 1 on the right side, and we put that on top of the 1 on the left side. So 1 over 1 is 1, and you put a plus minus in front of it. So if there are any rational zeros for this function, I'm not saying there are, but if there are any rational zeros for this function, they will be at either positive 1 or negative 1, or there won't be any. Okay, number 51. Notice the function is already written in standard form. We're going to list out all the factors of my lead coefficient, which is 2. The factors of 2 would be 1 times 2, and that's it. Now we list out all the factors of 8. Well, 1 times 8 and 2 times 4. Now we take each number over here and we put each number on top of each number over here. And don't forget to put plus minus in front of each one. So 1 over 1 is 1, so plus minus 1. 1 over 2 is 1/2, so positive negative 1/2. Check this off. You're done with the 1. Now we take the 8. 8 over 1 is 8, so plus minus 8. 8 over 2 is 4, so positive negative 4. Check off the 8. Next we use our 2. 2 over 1 is 2, so positive negative 2. And then 2 over 2 is 1, and we already have a 1 right here, so no need to list that again. And now we take our 4. 4 over 1 is 4, and we already have a 4 right here. And then we put 4 over 2 is 2, and we already have a 2 here. So we're finished. We used the 4. We took each one of these numbers and put them on top of each number over here. So if any rational zeros exist for this function, they will be somewhere in this list. Okay? All right, moving on to number 53. We make sure that our function is written in standard form, and it is. And then next we list out all of the factors of my lead coefficient. My lead coefficient is 15. The factors would be 1 times 15 and 3 times 5. Then I list out all of the factors of my constant term, which is 2. And that would be 2 times 1. Now take each one of these numbers and put them on top of each of these numbers. So here we go. 2 over 1 would be 2, so positive negative 2. 2 over 15 would be 2/15, so positive negative 2/15. 2 over 3 would be 2/3, so positive negative 2/3. And 2 over 5 would be 2/5, so positive negative 2/5. I took my 2, check it off, I put it on top of all the numbers over here. Now with 1 we'll do the same thing. So 1 over 1 would be a positive negative 1. 1 over 15 would be a positive negative 1/15. 1 over 3 would be a positive negative 1/3. And 1 over 5 would be a positive negative 1/5. So I'm not saying that there are any rational zeros that exist for this function right here, but if there are any rational zeros, if there are any that exist for this function right here, they will be somewhere in this list here. Okay? All right, moving on to numbers 53 through 69. And those directions state, find the rational zeros and the other zeros, and then factor into linear factors. So here we go. This isn't too hard. First of all, anytime you're looking for the zeros, try to factor first if you can, okay? That's very, very important to do. So we're going to find the zeros. We substitute a 0 in for y, or f of x, and we're going to try to factor this 4-term polynomial, okay? We're going to try to do that. And so you pull out what's common in the first two, which is x squared, and you're left with x plus 3, okay? And then we pull out what's common in this group because there's a negative sign right here. I will put a negative sign, and what's common is a 2, so I pull out a 2. Now, because I put an x plus 3 over here, I'm going to put an x plus 3 right here, and let's see if that works. It might, and it might not. Negative 2 times x is negative 2x, and negative 2 times 3 is negative 6. So it does work. I can factor out a negative 2, and I'm left with x plus 3. Okay, so you write your matching parentheses once, x plus 3, and then your other matching parenthesis, or excuse me, your leftovers would be x squared minus 2. Now, if I take this group here and set it equal to 0, I will get a negative 3. If I take this group here and set it equal to 0, I will get and solve, I will get a positive negative square root of 2. We should know how to do that by now. Now, I did what they asked us to do for step 1, which was to find the zeros for this function. I did that. But now notice something else they asked us to do. If you look in the directions, it says to write the function with linear factors. Now this x plus 3, please listen to me carefully. Here's your zeros right here. There are 3 of them. This parentheses here is a linear factor. Linear because the degree is 1. This parentheses is not a linear factor because your degree is 2. So this factorization is not good enough. Let me show you what they want you to do. They want you to find the zeros first, which we did, and then after you find the zeros, they then want you to take each 0 and change the sign and put it in a parenthesis. So for example, if we have negative 3 for a 0, then the linear factor is x plus 3. If we have positive square root of 2 for one of my zeros, then we're going to put x minus square root of 2. And if I have negative square root of 2 for one of my answers, one of my zeros, then I'm going to put x plus square root of 2 in my other parentheses. And there, now you've taken this expression here and you've written it with linear factors. And by the way, if you take each group and set each group equal to 0, you will get these 3 answers right here. It's totally fine. It totally works. Okay? So that's what they're asking you to do. I'm not sure if we really went over that well in class, but this will be a good practice for you, okay, as we do these during the homework. All right, let's continue on. Oh, and one other thing they asked us to do was tell which zeros are rational. The negative 3 is a rational 0. The square root of 2 is an irrational 0. Okay, moving on to 57. This is going to be one that we cannot factor. If I put a 0 right here, and I try to factor this, notice my exponent here is supposed to be twice as big as this exponent here, and it's not. So we really have not learned how to factor trinomials like this. So the next thing we have to do is we're going to have to list out the possible rational zeros and then test them and see if we can find them, okay? Find the real zero. So my lead coefficient is 1. The factors of 1 would be 1 times 1. I'm just going to put a 1. The factors of 2 would be 1 and 2. We take each of these numbers, put them on top of these numbers. 1 over 1 would be positive negative 1, and 2 over 1 would be positive negative 2. Now we're quickly going to test these possible rational zeros and see if any of them work. Do you remember how to do that quickly? First of all, we use synthetic division. So my third degree coefficient is 1. My second degree coefficient is 0. My first degree coefficient is negative 3. And my constant term is 2. Let's test positive 1. I'm going to put a positive 1 right here. And watch how fast I do this. Okay, students, it takes seconds. Bring down your 1. Multiply, you get a 1. Combine, you get a 1. Multiply, you get a 1. Combine, you get a negative 2. Multiply, you get a negative 2. And you get a 0. So it looks like, and I did not know that was an answer. Okay, I'm telling you right now I did not. But it looks like 1 worked. 1 gave me out a 0. So do you remember what to do? We did this in class. Remember what to do. You come off to the side and you say zeros equal and I found one of my zeros. It's a 1. Now we started off with an x cubed, so my leftovers here would be x squared, x in constant terms. So I have 1x squared plus 1x minus 2. Okay, now we cannot, yes, we can factor this. Actually, I believe we can. We should be able to factor this, and I believe when you factor this, yes, we can factor this trinomial. We have an x squared here and an x to the 1 power here, a lead coefficient of 1. What two numbers multiplied together give me -2, when added together give me a +1. Well, it's going to be a +2 and a -1. When you multiply those, you get a -2. When you combine them, you get a +1. So your factorization would be x plus 2, x minus 1. So if you take each one of these groups and set each one of these groups equal to 0, you will get a 0 of -2 and a 0 of +1. Okay? So -2, +1. There's your other zeros. And by the way, your degree was 3, so the maximum number of zeros you could have would be 3. Now, if I can read your mind, you're probably saying, Mr. Earhart, you don't need to write that 1 twice. And you're right, I don't. But here's why I did that. Listen to me carefully. Remember how the directions said to write this problem with linear factors? Well, that means we're going to have to write x minus 1 twice because there was a multiplicity of 2. So that's why I wrote both 1s, because I want to come over here and write my factorization correctly. So for the +1, I put x minus 1. For the +1, I put x minus 1. And for the -2, I'm going to put x plus 2. So here's my zeros. Now that I've written my linear factors over here, you don't have to keep this 1 in the list. You can if you want to. I wouldn't take off any points for that. But your zeros are 1 and -2. And you have taken this expression here and you've written it with linear factors. Okay? Moving on to number 59. Now please trust me on this. If you tried to factor this, you would not be able to. So we're going to jump right into listing out our possible rational zeros. Well, I have a 1 here. It's written in standard form. The factors of 1 would be 1. The factors of 17 would be 1 and 17. Put 1 over 1, that's a positive -1. Put 17 over 1, that's a positive -17. So if any possible rational zeros exist, it'll be one of these 4 numbers here. And maybe none exist. Okay, we're going to find out. So let's go ahead and use synthetic division, and let's see if we can't test these numbers right here. Okay, let's slide this over here, and here we go. For my third degree coefficient is a 1, -5 is my second degree coefficient, 11 is my first degree coefficient, 17 is my constant term. I'm going to go ahead and test 1 first, +1, and let's see what happens. It's really fast. Bring your 1 down, multiply, that's a 1, combine, that's a -4, 1 times -4, -4, combine, you get a 7, 1 times 7 is 7, combine, you get 24. So we can stop right there. We know that +1 is not going to be a 0. So all that you do is just simply erase this, and then we do it again. Now I'm going to put a -1 here. Bring down your 1, and I guess also I needed to, that's my fault, I need to erase this row too. Okay, bring down your 1, -1 times 1, -1, combine, -6, -1 times -6 is 7, combine, you get 17, -1 times 17 is -17, combine, you get a 0. Look at that. Okay, so now we know -1 is one of your zeros, so we're going to write zeros equal -1. Now we started off with an x cubed, so these leftover numbers here are going to be a quadratic, so 1x squared minus 6x plus 17. Now you cannot factor that. Go ahead and try. You'll see you cannot factor it. There are no two numbers multiplied together that give you 17 when added together give you 6. So the only thing left for you to do is to use your quadratic formula. So here we go. Negative b, I'm going to write it and erase it. Negative b plus minus the square root of b squared minus 4ac all over 2a. I'm going to erase this, so if you want to pause the video and write that down, feel free to do that. Okay, here we go. negative b, but b is already a negative 6, so negative 6 is a positive 6. And then positive negative square root of b squared, that would be 36. And then negative 4, and then a times c, and a times c would be 17 over 2a, and a is 1, so 2 times 1 is 2. All right, let's simplify under the radical right here. We have 4 times 17 and negative 4 times 17. That's going to give us a negative 68. So we really have 6 positive negative square root of 36 minus 68 all over 2. And that will then give us 6 positive negative the square root of negative 32 all over 2. Alright, now let's continue. We have a lot of simplifying to do, so please pay attention, okay? I'm going to make this 32 positive and put an I right here. And then for 32, I'm going to put 16 times 2. And then cross off the 16 and put a 4 right here because the square root of 16 is 4. So now I have 6 positive negative 4. Now remember, I had 16 times 2 inside the radical. The 16's gone. I'm still left with a 2 right here, then an I, and then a 2. Now this is an outside number, this is an outside number, and this is an outside number. So all of those are reducible by 2. This will become a 1, this will become a 3, and this will become a 2. So your other two zeros would be 3 plus minus 2 square root of 2I all over 1, but you don't need to write that. So there's your zeros. You found them all, the real and the imaginary. Okay? Now, like they said, students, they do want us to then write this expression here with linear factors. This expression right here. So remember what to do. My 0 is negative 1, so I'm going to put x plus 1. And then be careful here. These are two zeros. Really, one of your zeros is 3 plus 2, square root of 2I. And the other 0 is 3 minus 2, square root of 2I. So what you want to do, let's take this 0 first. Just like you put for the negative 1 right here, you put x plus 1. Well, here you're going to put x. And then if positive 3, instead of positive 3, positive 2, you're going to put negative 3, negative 2, and then square root of 2, and then I. And then same thing for this 0 right here. Instead of putting positive 3, negative 2, you're going to put x, and then negative 3, positive 2, and then square root of 2I. This is a linear factor, this is a linear factor, and this is a linear factor. We know they're all linear factors because your x has a power of 1, okay? So we found the zeros, and then we wrote this as a linear factor. Moving on to number 61. Okay, we definitely can't factor this because it's 5 terms, so we're going to list out the possible rational zeros, okay? Now, it's already written in standard form for us, so we're fine there. The lead coefficient is 5, the constant term, or excuse me, the factors of 5 would be 1 and 5, and the factors of 4, your constant term would be 1 times 4, and 2 times 2. We'll just write the 2 one time. Now put 1 over 1, that's positive negative 1. 1 over 5, that's positive negative 1/5. And then 4 over 1, that's a positive negative 4. And then 4 over 5, that's a positive negative 4/5. And then 2 over 1, that's a positive negative 2. And then 2 over 5, positive negative 2/5. If any rational zeros exist, I'm not saying they do, but if they exist for this function right here, then they will be somewhere in this list right here. So we're going to have to start checking each one of these numbers, okay? I just usually start with the positive 1 and work my way through, so that's what I'm going to do. Alright? Alright, here we go. I'll put a positive 1 inside my box. Write out your coefficients. It looks like we're not missing any terms, so we're going to put a 5, and then a negative 4, and then a 19, and then a negative 16, and then a negative 4. Let's bring down the 5. 1 times 5 is 5. Combine, you get 1. 1 times 1 is 1. Combine, you get 20. 1 times 20 is 20. Combine, you get 4. And 1 times 4 is 4. And that will give you a 0. So look at that. 1 is one of our zeros. So z equals 1. Now we started off with the 4th degree, so these leftover numbers here are going to be a 3rd degree, one less. So we're going to have 5x cubed plus 1x squared plus 20x plus 4. And I think this is factorable. So I think we can take this leftover part right here, and I'm pretty sure we can factor it, which will then give us the rest of our zeros. So let's see what happens here, okay? This is a 4-term polynomial. Let's pull out what's common in the first two. That would be an x squared, and you're left with 5x plus 1. And then here, there's a common 4, so pull out a 4, and you're left with 5x plus 1. So far it looks good. Write your matching parentheses once, 5x plus 1. Write your other matching parentheses, or not your other matching, sorry. Write your leftover terms right here in your other parentheses, x squared plus 4. And there we did it. We took this expression here and we factored it down to this. So now, if you took this expression here, right here, and set it equal to 0 and solved, you would get negative 1/5. So there's another 0 for you, negative 1/5. And then if you took this expression right here and set it equal to 0 and solved, you would get positive negative 2i. Positive negative 2i. And I'm not really taking time to do that for you. I guess I could, but I'm just pretty sure we know how to take this, set it equal to 0, bring your 4 over, make it a negative 4, and then take the square root of both sides. So it looks like we have found all of our zeros. We found 4 zeros, 1, 2, 3, 4, and the degree of the original problem is 4, so we know we can't have more than 4. So we have found all of the zeros. Now some of these are real, some of these are imaginaries. This is a rational 0, this is a rational, these two are imaginary, but we have found all the zeros. Now they want us to write this expression right here with linear factors. So we take each individual 0 and we change the sign and put it with x. So a 0 is positive 1, so I'm going to put x negative 1. One of my zeros is negative 1/5, so I'm going to put x plus or x positive 1/5. One of my zeros is positive 2i, so I'm going to put x minus 2i. Okay. One of my zeros is negative 2i, so I'm going to put x plus 2i. And there, you did it. You wrote this polynomial expression right here into linear factors. All right. Moving on to number 63. Okay, once again, we cannot factor this. It has 5 terms, so we're going to list out our possible rational zeros and then test those numbers and find some zeros, okay? So my lead coefficient is 1, the factors of 1 would be 1. My constant term is negative 8, so the factors of negative 8 would be 1, 8, 2, and 4. 1 times 8, 2 times 4. Well, 1 over 1 is a positive negative 1, 8 over 1 is a positive negative 8, 2 over 1 is a positive negative 2, and 4 over 1 is a positive negative 4. So there's my list of possible rational zeros. Okay? And I'm going to take this list here and test some numbers. It looks like I'm not missing any terms. I have a 4, then a 3, then a 2, then a 1, then a constant term. So my coefficients will be 1, negative 3, negative 20, negative 24, and negative 8. Now, I guess I will go and start with my 1's first, and I will check a positive 1. So let's see what happens here when I test a positive 1. Bring your 1 down, multiply 1 times 1, you get a 1, combine, you get a negative 2, 1 times negative 2 is negative 2, combine, you get a negative 22, 1 times negative 22 is negative 22, combine those, you get a negative 46. You can see right away you're not going to get a 0 here, so you can go ahead and stop, and we will be left with now checking a negative 1. So let's check a negative 1. Bring down your 1, negative 1 times 1, negative 1, combine negative 4. Negative 1 times negative 4 is 4, combine you get a negative 16. Negative 1 times 16 would be a positive 16. Combine you get a negative 8. Negative 1 times negative 8 is a positive 8, and you do get a 0. So it looks like for number 63, one of your zeros will be a negative 1. Okay? Now, let's go ahead and put zeros right up here. Z equals negative 1. We start off with the 4th degree, so these numbers right here are going to be 3rd degree. So I have 1x cubed minus 4x squared minus 16x minus 8. Now, if you try to factor this, I'm pretty sure you're not going to be able to do it, okay? So we're going to have to continue checking our rational zeros. Now, I'd like to say that you can use this expression now. You no longer have to use this one. You've broken it down to this. And sometimes negative 1 will work again. Now, in this case, I don't think it does. I'm pretty sure it doesn't. But we'll go ahead and try it anyways. We know positive 1 is still not going to work. That's not a 0. But anyways, my coefficients would be 1, negative 4, negative 16, negative 8. We'll go ahead and try the negative 1. Sometimes you get a multiplicity of 2. So even though we already know negative 1 is a 0, negative 1 might work again. Bring down your 1, multiply, you get a negative 1, combine, you get a negative 5, multiply, you get 5, combine, you get negative 11, and we're not going to get a 0 here. So negative 1 does not have a multiplicity. Now let's go ahead and try a positive 8. A positive 8. All right. Bring down your 1, multiply, you get an 8, combine, you get a 4, multiply, you get a 32, combine, you get 16, and we're not going to get a 0 here. Now, looking ahead, I'm going to tell you right now, I've done a lot of these just to show you how to do this. I believe 2 or negative 2 actually works. So let's go ahead and throw in now a negative 2 and see if that works, okay? All right, bring down your 1, multiply, you get a negative 2, combine, you get a negative 6. Negative 2 times negative 6 is positive 12, combine, you get a negative 4. Negative 2 times negative 4 is positive 8, we get a 0. So that was an x cubed expression, so these right here will be an x squared. So we have 1x squared minus 6x minus 4. Now, if you try to factor this right here, it's just not factorable. There are no two numbers when multiplied together that give you a negative 4, but when combined, that gives you a positive or a negative 6. Excuse me. So we're going to have to use again the good old quadratic formula, which is okay. Oh, by the way, I forgot to write my 0 up here. Negative 2 worked, so let's put a negative 2 up here for my 0. All right. Now let's see if we can erase some of this. Erase some of this. Pull this up. And let's use the quadratic formula on this quadratic, okay? All right, negative b, well, 6 is already negative, so negative negative 6 is positive 6. Positive negative b squared would be 36 minus 4ac. 1 times negative 4 would be negative 4. And then 2a, 2 times 1 is 2. Okay, let's simplify the radicand, the number under the radical. First of all, you multiply negative 4 times negative 4, you get 16. 36 plus 16 would be 52. So we have 52, square root of 52 all over 2. Now 52 can be broken down into 6 plus minus. One of your perfect squares, 4, goes into 52 13 times. So 4 times 13 is 52 all over 2. Now cross off the 4, take the square root of 4, put a 2 right here on the outside, and we're left with 6, positive negative 2, square root of 13 all over 2. And now these three are your outside numbers, and 2 goes into all of them. So 2 goes into 2 once, 2 goes into 6 3 times, 2 goes into 2 once. And so you really have 3 positive negative 1 square root of 13 all over 1. And you don't need to put it over 1 if you don't want to. So we're going to grab these two zeros here and pull them up here. And look, what was the degree of our original problem? 4. So what's the maximum number of zeros we can have? 4. And how many zeros do we have? 1, 2, 3, 4. We have two rational zeros, -1 and -2, and we have two irrational zeros, 3 plus the square root of 13 and 3 minus the square root of 13. Now, all four of those zeros are real. None of them are imaginary, but these two here are rational and these two here are irrational. Now, remember what to do? They now want us to write this function right here with linear factors. So, if one of your zeros is -1, we're going to put x plus 1. If one of your factors is -2, we're going to put x plus 2. If one of your factors is 3 plus the square root of 13, I'm going to put x minus 3 minus the square root of 13. If one of your factors is 3 minus the square root of 13, then I'm going to put -3 positive square root of 13. All right, so there we go. So we found all four zeros. They're right here, and we listed out the four linear factors. And having done that, let's go ahead and move on. Number 65. Number 65. Okay, you cannot factor this. If you tried to factor it, it would not work. So let's go ahead and list out our possible rational zeros. It's written in standard form already. Your lead coefficient is 1. The factors of 1 would be 1. And the factors of 4 would be 1 times 4 and 2 times 2. So 1 over 1 is positive -1. 4 over 1 is positive -4. And 2 over 1 is the positive -2. All right? Now, you can really start with any number that you want. We've done a lot of these, and I am trying to save time on the homework help video. So I'm going to go ahead and just do a little bit of cheating here. You'd have to test these numbers quickly, okay? But as you test each one and see that some of them fail and some of them do not fail, you're going to come across 2, and you're going to see that positive 2 does work. I'm going to show you that right now. It looks like we're missing no terms. We have a 3, then a 2, then a 1, then a constant term. So my coefficients are 1, -4, positive 2, positive 4. And now bring your 1 down. 2 times 1 is 2. Combine, that's a -2. 2 times -2 is -4. Combine, you get a -2. 2 times -2 is -4. And that gives you a 0. Okay, so we know now that one of my zeros would be 2. And you're left over, you start off with a third degree. Now I have 1x squared minus 2x minus 2. Now if you tried to factor that, it would not be possible, okay? You cannot factor that expression. So we're going to have to do our wonderful, exciting thing that we like to do, and that is to use the quadratic formula, okay? Quadratic formula. So here we go. Negative b, well, b is already a -2, so -2 is a positive 2. And then positive negative square root of b squared. If you square a -2, you get 4. And then minus 4ac. So minus 4. And then a times c, 1 times -2 would be -2. All over 2a, 2 times 1 is 2. Now if you simplify the radicand, that's the part under the radical, you would multiply 4 and 2, that's a positive 8 plus 4 is 12, all over 2. And then you know you can rewrite 12 using a 4 because 4 is a perfect square, so 4 times 3 is the same thing as 12. Now cross off your 4, take the square root of it, and come out here and put a 2 because the square root of 4 is 2. So now we have 2 positive -2 square root of 3 all over 2. Well, these three outside numbers are all 2, so we can reduce them all by 2. So 2 would go into 2 once, into 2 once, into 2 once. So you're left with 1 positive -1 square root of 3. And you don't have to put this 1 right here if you don't want to. Okay, so there's your other two zeros. And that's a total of 3 zeros. And you know what? That's exactly right, because the degree of your original problem was 3, and you can have no more than 3 zeros, a maximum of 3 zeros. Okay, so we found all the zeros. Notice we have 1 rational zero here and two irrational zeros here. And now we're going to write our answer, or our original problem, our function with linear factors. So if one of my zeros is 2, I'm going to put x minus 2. And sometimes it helps to write these zeros out individually. So I'm going to try to do that real quick here. All right. So there we go. So one of your zeros is 1 plus the square root of 3, and 1 is 1 minus the square root of 3. So when I take this 0 right here and put it back into the parentheses it came from, it's going to be x negative 1 negative square root of 3. And now when I take this expression right here and put it back into a linear factor, it's going to be x, and then we have a positive 1, so negative 1. We have a negative square root of 3, so a positive square root of 3. And there, you did it. You took 65 and you wrote it with linear factors. All right, number 67. Now, this is kind of an old one here, and we can actually factor this. It's called the sum of two cubes. It's been a while, but we really should know how to do this. And what you do is you put a little parentheses and then a big parentheses, and we do know how to factor this. The cube root of x cubed is x. The cube root of 8 is 2, and whatever sign you have here, you bring that down. So I put a plus sign here. Now whatever this term is right here, your x, you multiply that by itself. X times x is going to be x squared. And then whatever this term right here is, you multiply it by itself. 2 times 2 is 4. It goes right here. And then you take this term and multiply them together, and x times 2 is 2x. Now, whenever there's a positive sign here, the sign sequence is going to go positive, then negative, then positive. Now, we studied that a long time ago, and I know it's not easy to remember all of this, but that is the way you would factor that. So this is okay here. We know the factor for this parentheses here was going to be negative 2. But for this one here, you can't factor this. So I know it's getting really old, but we're going to have to use the quadratic formula on this. So for this parentheses here, I'm done with x plus 2. I already know one of my zeros will be negative 2. Now I've got to use the quadratic formula on this. So I'm going to go pretty fast, okay? All right, negative b, that's a negative negative 2, positive 2. Positive negative, the square root of b squared would be 4. And then minus 4 ac, 1 times 4 is 4. And then 2 all over 2 times 1, 2 times a, 2 times 1 is 2. Okay, if we then simplify the radicand, 4 minus 16 would be negative 12 all over 2. Okay, and then if you make this positive and put an I on the outside, the next thing you can do is take your 12 and rewrite it as 4 times 3. Cross off the 4, put a 2 right here. So now we're left with 2 positive negative 2 square root of 3 I all over 2. Now notice your outside numbers are 2, 2, and 2. So 2 goes into each of those numbers one time. And now we're left with 1 positive negative square root of 3I. Okay? Now, let's come up here. We found our other two zeros, so I'm going to put one of them here. 1 plus square root of 3I. And the other 0, 1 minus square root of 3I. Now that's 3 zeros, and the highest, my degree of my original equation was 3. That's the maximum number of zeros you can have. Notice we have one rational and then 2 imaginary numbers. Okay? And so we're going to go ahead and write our linear factors. So if I have negative 2 for a 0, my factor is x plus 2. If I have 1 plus square root of 3i, my factor would be x negative 1 negative square root of 3i. And then the other expression is going to be x minus 1 plus square root of 3i. Okay? So here are your 3 zeros. and here would be the linear factor for each one of those zeros. Okay. All right, one more in this section, then we'll move on to another section. All right. This one here is going to be pretty tough. Not really looking forward to this one here, but we'll go ahead and do it pretty quickly. Factoring it could be possible to factor. You never know. Actually, it could be. The more I look at it, I can see you could not factor it. So we're going to list out the factors of 1/3. Wow. I mean, that's going to be really tough. Trying to think of the best way to do this. This is a real unique problem, and I probably would not give you one like this in a test, but here's what I would think I would do. Notice you have a 1, a 3, a 2, and a 6, and a 6. I think I'm going to do something a little interesting here. I can pull out any number I want as long as I pull it out of everything. I'm going to pull out a 1/6. And just reason with me and watch. If I take 1/6 times 2, that gives me x cubed. That means if I take 1/6 times 2, it gives me 1/3 x cubed. If I take 1/6 times a -3, that would give me a -1/2. If I take 1/6 times -1, that gives me a -1/6, and then a +1 here. Now look what I've done. You can trust me on this, or you can take your calculator and check my work. But if you take a 1/6 and multiply it back through, it'll give you what you started with. So what I did is totally legal. I factored out a 1/6. Now that really leaves me with some nice numbers to use here. Okay, so notice that my lead coefficient now is a 2. Okay, and so my lead coefficient here is 2, so the factors of 2 would be 1 times 2. And then notice also I have my constant term, and the constant term factors would be 1. Put 1 over 1, that's positive -1. Put 1 over 2, that's positive -1/2. Now I'll admit, throughout most of these problems, except for the last one and this one, I've just tested numbers until I found one that works. Okay, but in this case here, to save time, I'm going to go ahead and tell you now. You can check each one, check +1, check -1, check +1/2, check -1/2, and see which one of those are zeros. You're going to see it is +1/2, and I'm going to show that to you. Excuse me for yawning, I apologize. I'm going to show that to you right now. Okay, I'm going to put a +1/2 here, and then put my coefficients, a 2 here, a -3 here, a -1 here, and a 1. Okay, let's bring down our 2. 1/2 times 2 is 1. Combine, you get a -2. 1/2 times -2 is -1. Combine, you get a -2. 1/2 times -2 is -1. Combine, and you will get a 0. So we started off with an x cubed, so our leftovers here would be x squared. So 2x squared minus 2x minus 2. So I come up here and I write zeros equal 1/2. So we found one 0. When you put in 1/2, you got out a 0. Now that leaves me with this trinomial quadratic right here, but it's not factorable. It is not factorable. You cannot factor that, so we're going to have to use the quadratic formula. Okay, so here we go. -b, b is already negative, so -2 is a +2, plus minus the square root of b squared. 2 times 2 is 4, minus 4ac. That's -4 all over 2a. 2 times 2 is 4. Next, it's 2 positive negative square root of 20 all over 4. And then we're going to have next 2 plus minus for 20. I'm going to put 4 times 5 all over 4. Cross off the 4 and put a 2 on the outside. And now you can reduce your outside numbers 2, 2, and 4 by 2. And 2 would go into 2 once, 2 would go into 2 once, and 2 would go into 2, or 2 would go into 4 twice. So 1 positive negative square root of 5 all over 2. Okay, so now I found my other two zeros. So 1/2 is 1 0, and then my other two zeros would be 1 positive negative square root of 5 all over 2. Now these are fractions, and let me show you something here. Well, first of all, we found our zeros. Okay, we found our zeros, and that's good. Now I'm going to kind of write them a little different. In fact, I'm going to grab this. One of my zeros is 1/2. So here's my zeros. 1/2, comma. Then I'm going to put 1 positive square root of 5 over 2, and then 1 negative square root of 5 over 2. Now I usually wouldn't write my zeros like this. I would leave these two zeros in this form right here. But again, don't forget I'm writing linear factors, and it helps so much when you write linear factors to have all of your zeros listed out separately. So one parentheses for the negative 1/2 or for the positive 1/2 is going to be x minus 1/2. And then watch how we do this. Because we have a really big fraction here, if you start changing signs, it's going to be a mess. So I'm just going to put x minus the whole fraction, 1 plus square root of 5 all over 2. And then over here for this fraction, x minus the whole fraction, 1 minus square root of 5 over 2. And that's totally acceptable, okay? So we found your three zeros, and then we rewrote the original function with linear factors. So not too bad, okay? All right. Let's continue on to numbers 71 through 77. Now they say to find only the rational zeros. So find only the rational zeros. Okay, no big deal. This will not be near as hard as the other one, because if we have any quadratics that we have to use the quadratic formula on, we can just stop, because we know that's going to be an irrational zero. Okay, so we're looking for only rational zeros. So I cannot factor this. I list out the possible rational zeros. The factors of 1 would be 1. The factors of 6 would be 1, 6, 2, and 3. 1 over 1 is a positive negative 1, 6 over 1 is a positive negative 6, 2 over 1 is a positive negative 2, and 3 over 1 is a positive negative 3. Now, you can check each one of those zeros over and over until you find a zero. I'm going to tell you right now 1 is going to be one of your zeros, so I'll put a 1 here, and then write out my coefficients. Notice I'm not missing anything. I have a 4, 3, 2, 1, and a constant term. So my coefficients are 1, 2, negative 5, negative 4, and 6. Bring down your 1, multiply, combine, multiply, combine, multiply, combine, multiply, combine. So we started off with an x to the 4th, and now we're down with an x to the cube. So 1x cubed plus 3x squared minus 2x minus 6. And this is factorable. Pull out what's common in the first two. You're left with x plus 3. You can pull out a 2 here, and because there's a negative sign here, we'll make it a negative 2. And you're left with x plus 3. So your matching parentheses, you write those ones. And then your other parentheses, there should be an x squared right here, shouldn't there? Sorry about that. You pulled out an x squared. So your other parentheses would be x squared minus 2. Now, okay, we already found 1 0. It was a 1. So 0 equals 1. Now, if you set this group equal to 0, you get a negative 3. So that's another rational 0. Now, be careful here. If you set this group equal to 0 and solved, you'll get positive negative square root of 2, and that is not rational. That's an irrational number. They don't want you to write that. They just want you to find the rational zeros. Okay, number 73, you cannot factor this. Trust me, if you try, you will not get out matching parentheses. So we make a list of our possible rational zeros. There's a 1 here. The factors of 1 would be 1, and the factors of 3 would be 1 times 3. 1 over 1 is positive negative 1. 3 over 1 is positive negative 3. Now, you're going to have to check those numbers, and when you do, you're going to see that all 4 of these numbers fail. Not one of these rational zeros. None of these numbers work for rational zeros. So the answer to this is we have no rational zeros. None. No rational zeros for this expression, okay? Number 75. We cannot factor a 5-term expression, but we can make a list of the possible rational zeros. I have a lead coefficient of 1. The factors of 1 would be 1. The factors of 8 would be 1 times 8 2 times 4. 1 over 1 is a positive negative 1, 8 over 1 is a positive negative 8, 2 over 1 is a positive negative 2, and 4 over 1 is a positive negative 4. Now what you'd have to do next is start testing each of these numbers, okay? I'm not going to take time and test them all for you, but just trust me, if you checked each one of these, it would take about 3 minutes, but you will see none of them work. None of them. So this expression has no rational zeros. If it has any zeros at all, they will be irrational zeros or imaginary. Okay, moving on to number 77. Okay. Notice I cannot factor this, so I list out the possible rational zeros. I have a lead coefficient of 1. It is written in standard form, the function is. The factors of 1 would be 1, and the factors of your constant term 20 would be 1 times 20, 2 times 10, 4 times 5. Now if you put each one of these numbers over 1, you'll get positive negative 1, positive negative 20, positive negative 2, positive negative 10, positive negative 4, positive negative 5. Okay, so if there are any rational zeros for number 77, they will be in that list right there. Okay, and you can check as many as you want, but I can see for sure that negative 2 is going to be one of your zeros. Okay, so I'm going to put a negative 2 in my box here, and then notice I'm not missing any terms. I have a 5, 4, 3, 2, then a 1 here, and then a constant term. Okay, so I'm not missing any terms. So my coefficients would be 1, negative 5, 5, 15, negative 36, 20. Then bring down your 1, multiply negative 2, combine negative 7, multiply, that's 14. Combine, you'll get a 19, multiply, that's a negative 38. Combine those, and you will get 20, let's see, 15, 25, 35, 33, so a negative 33. And then if you multiply, and for some reason this isn't working, let me check my work here. Negative 2 is supposed to work. 1, negative 5, 5, negative 36, 20. Well, let's see what happens here. 15, maybe this should be, I think this is a 15, yeah, this should be a negative 23. There we go. Yeah, negative 23. Multiply, you get a positive 46. Combine, you get 10. Multiply, you get a negative 20. And so there we go. So we started off with a power of 5. So all of these here will be a power of 4. So I now have 1 x to the 4th minus 7x cubed plus 19x squared minus 23x plus 10. Alright, so I took my original problem and I broke it down to this right here. That's not too bad. So I found one of my zeros. It was a negative 2. I just showed you when you take a negative 2 and test it using synthetic division, you do get out that negative 2 is one of your zeros. So 0 equals negative 2. Alright, now what do we have here? Positive, negative 12, 2 times 10, 4 times 5, that's a positive 5. Okay, well if you continue to check your rational zeros list, you're going to see that 1 works, okay? So now we're going to put a 1 inside the box and now use our coefficients. No terms are missing. So a 1, then a negative 7, then a 19, then a negative 23, and then a 10. Alright? So bring your 1 down, multiply, you get 1, combine negative 6, multiply negative 6, combine, you get a 7, multiply, you get a 7, combine, you get a negative 16. And once again, I think I'm making a mistake somewhere here, which is pretty standard for me probably. Let's see here, multiply 1, negative 6, negative 6. Yes, this would be a 13 right here, a 13. And 1 times 13 would be 13. Combine, you'll get a negative 10, and 1 times negative 10 is negative 10. So we started off with an x to the 4th. So these numbers right here will start off with an x cubed. So I have 1x cubed minus 6x squared plus 13x minus 10. Boy, I wish I could factor that, but I just can't. So another one of my rational zeros is 1. I tested 1 right here, and I got at a 0. Okay? So now I'm ready to continue on, keep testing all these zeros in your list. And I know that it's not fair that I just say the next 0 is this, but I am trying to save time. You have to continue testing these numbers in this list, and the next 0 you will come up with will be a positive 2. At least it should be. So I'm missing no terms here. My coefficients are 1, -6, 13, and -10. Bring down your 1, multiply, combine, multiply, combine, multiply, and combine. So now you're left with x squared minus 4x plus 5. Okay? And if you try to factor this, you will not be able to. You will not be able to. There are no two numbers that multiply together give you a positive 5 when added together give you a -4. So if you can't factor this, you're going to have to use the quadratic formula. But hold it, if you use the quadratic formula, you're going to get out a rational expression. Okay, so we're done. Don't forget this is a 0 here. So your last rational 0 is positive 2. So we did what the directions said. We found all of the rational zeros that exist. Okay, all right, that's number 77. Moving on to number 79. Number 79 to 93, we're going to use Descartes' rule of signs to give us some hints about the positive real zeros and the negative real zeros. So here we go. I am going to go pretty fast on these, so listen carefully, okay? First of all, I look for sign changes in the original problem. I go from a positive to a negative, that's one sign change. Then a negative to a positive, that's another one. And then from a positive to a negative, another one. So I have 3 sign changes. So I know this about my positive zeros. I had 3 sign changes, so I know I'm going to have 3, then subtract 2, or 1, and then you keep subtracting 2 until you get to negative or 0, so I'm done. I can't subtract 2 from 1, so I know I'm either going to have 3 positive zeros or I'm going to have 1 positive 0. Okay, that's pretty simple. Now the negative zeros is still pretty easy. Everywhere there's an x, you're going to put in a negative x. So if I have a negative x to the 5th power, that's going to be a negative x, because this number here is odd. Negative times a negative times a negative times a negative times a negative. So if I put in a negative x for x, and then for this x put a negative x, and then for this x a negative x. Negative x to the 5th power is a negative x times 3 is a negative 3x to the 5th. If I put a negative to the 2nd power, that's going to be a positive times a negative 2 is going to be a negative 2x squared. And then negative times a positive is a negative x, and then minus 1. So, excuse me, I see no sign changes. Negative, 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 negative. So I have 0 sign changes. So now I know that I will have no negative zeros, none, because there were no sign changes. This is really a helpful rule. It will help a lot. All right, number 81. First of all, we look for sign changes in the original problem. We have positive, 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 positive. There's no sign changes, so we know our positive zeros, there are none. Okay? Positive zeros, there are none. Now let's check for negative zeros by putting in a negative x everywhere there's an x. If you put a negative x in, take it to the 7th power, that's a negative x times 6. That's a negative 6x to the 7th. A negative x to the 2nd power is a positive x squared times a positive 2 is a positive 2x squared. If you put a negative x in for x, 5 times negative x is negative 5x. And then positive 4. So we have a sign change here, negative to positive, 1 here from a positive to a negative, and 1 here from a negative to a positive. So your negative zeros for number 81, there were 3 sign changes. We went from a negative to a positive, that's one, a positive to a negative, that's another, and then negative to a positive, that's another. So we have three sign changes, so we're either going to have three negative zeros, now subtract 2. You always subtract 2, or you're going to have one negative 0, okay? And that's number 81. Okay, let's move on to number 83, all right? Number 83. Okay, hopefully you're catching the kind of the way to do this. I'm going to go a little faster now. Let's look for sign changes in the original problem. We have positive, positive, and a negative. So there's one sign change. Then a negative to a positive, that's another one. And then positive to a positive. So we have two sign changes. So we know for our positive zeros, there were two sign changes. So I'm going to have 2, then subtract 2. And you'll get 0. So I know there's either going to be 2 positive zeros or no positive zeros, one of those two scenarios. Now, let's put negative p's in everywhere there's a p. If you put a negative p into the 18th power, that's a positive p times 3. That's going to give you a positive term. We'll put a negative here, a negative to the 4th power, a negative p to the 4th will be positive, times 2 will be positive. Negative p to the 2nd power is going to be positive, times the negative 5 will be negative. We're going to put a negative p here, and a positive and a negative would be a negative, and then bring down your positive 3. So I have positive, positive. Here's a sign change, positive to negative, and here's a sign change, negative to positive. So for my negative zeros, it looks like I will have 2 or 0 negative zeros, okay? All right, moving on to number 85. We have a positive, then a positive, here's a positive to a negative, and then a negative. So there was one sign change. So for my positive zeros, I know I have 1, and that's it. You can't subtract 2 from 1, so I know I have 1 positive 0. That's a big help. Now let's take a look at the negative zeros. If there's an x, you put a negative x, so negative x to the 6th power is positive times 7 is positive. Negative x to the 4th power is positive times the positive is positive. Put a negative x right here, and for x, there's already a negative sign up front, so negative negative is a positive x. And then bring down your negative 10. So I have a positive, then a positive, then a positive, then a negative. So a positive to a negative is one sign change. So I know that I will have, for my negative zeros, I will have 1, and that's it. You can't subtract 2 from that. So I know there's 1 negative 0, okay? That's a big help. Let's move on to number 87. Let me get a drink here real quick. Okay, let's look at the original problem. We go positive, positive. Here's 1, negative to positive. So I know my positive zeros will be 1. I know I'll have 1. Now let's put negative t's in. Negative t to the 5th would be negative times a negative 4 would be a positive term. Put a negative t here. Negative t to the 3rd power is negative times the negative sign out front would be positive. Put a negative t in here. And negative t squared is positive times the positive is positive, and then you have a positive 1. Well, there's no sign changes at all, and so I know for my negative zeros, I'm going to have no, for my negative zeros, excuse me, I know I'm going to have none, okay? There were no sign changes at all. All right, number 89, here we go, positive, positive, then look at this, positive to a negative, that's 1, then negative to a positive, that's 2. So I know for my positive zeros, I had 2 sign changes, so I will have 2, then subtract 2, or 0. So I will have 2 or 0 positive zeros. And now let's put a negative y in for y to the 4th. That gives you out a positive. Put a negative y in here. That gives you out a negative times the positive 13 is a negative. Then put a negative y in here. A negative times a negative would be a positive. And then bring down your positive. So we have a sign change from here to here. That's 1. And from here to here, that's 2. So it looks like my negative zeros It looks like I will have 2 or none. Okay? 2 or 0, negative zeros. All right, number 91. Let's see. Sign change from here to here, from here to here, and here to here. So 1, 2, 3. So for my positive zeros, there were 3 sign changes. So I'm going to say we have 3 positive zeros and subtract 2, or 1. We have 3 positive zeros or 1. One of those two scenarios. All right, now everywhere there's an x, I'll put a negative x. Negative x to the 4th power would be a positive. Negative x to the 2nd power is positive times the negative is negative. Negative x right here, 20 times negative x would be a negative, and then negative 24. All right, let's check our signs. A sign changed from positive to negative, and then nothing else changes. So for my negative zeros, I know that I will have 1. Okay, 1, negative 0. You don't subtract 2 from 1 and go into the negative numbers. You don't do that, okay? All right, this was number 91. Let's continue on to number 93. All right, let's start with the original problem. I go from a positive to a negative, that's 1. The negative to a negative, that's not 1. So I know for my positive zeros, I see 1 sign change. 1. Now let's put negative x's in everywhere you see an x. Negative x to the 5th power is negative times the positive 3 is negative. Negative x to the 3rd power is negative times the positive times the negative would be a positive. And then put a negative x in here. Negative 4 times negative x would be a positive. So I only see 1 time change. There it is. And so my negative zeros, I know for sure that I'll have 1. Okay, I will have 1, negative 0 for sure, because I had 1 sign change right here after I had substituted my negative x's in everywhere there was an x. Okay, all right, that's numbers 93. Let's jump on to 95 and 97 real quick, then we'll be done. I think these are pretty simple. I'm pretty sure you can factor to find the zeros, and we've done these before. I'm looking really quick. Yeah, both of these are factorable, so these shouldn't be too difficult. Okay, numbers 95 and 97, they want us to graph these. Let's go ahead and do this really quickly here. Go ahead and get a coordinate plane up here. And we'll go pretty fast. I gave you some steps. These are kind of review problems here. These last two, I gave you some steps on graphing these. And I don't have the steps in front. I could pull them up, but really, it's just the main basic things you have to do. For example, the first thing we're going to do in a second is check the end behavior of the graph, the end behavior. So we'll do that now. Here we go. It is written in standard form. Notice I have an odd degree and a positive lead coefficient. And if you'll look in your notes, or hopefully have it memorized, that means the graph will go down to the left and up to the right. Okay, next we find the x-intercepts by putting 0 in for y. So 0 equals, I'm going to pull out what's common in the first two. X squared. Then pull out what's common in the second two. I'm going to put 4x plus 1 and see if that works. Negative x, negative 2. Yep, that works. And so now you're left with 4x plus 1, your common parentheses, and then x squared minus 2. Okay, so if you found the zeros for this parentheses, you would get a negative 1/4. If you found the zeros for this parentheses here, you would get plus minus square root of 2. Now plus minus square root of 2, I'm going to my calculator here very quickly. Let's see here. The square root of 2 is going to be pretty small. It's going to be 1.4. Okay, 1.4. So let's get all of our zeros on here. I have one at negative 1/4. That's right here. Then I have one at negative 1.4. I'm going to put negative 1.5. and then a positive 1.5. So there's your 3 zeros. Now, let's quickly find the y-intercept. That's one of the next things that we always did, was find the y-intercept. In order to find the y-intercept, everywhere there's an x, you put a 0. So 0 cubed times 4 is 0. 0 squared is 0. A times 0 is 0 minus 2. 0 plus 0 minus 0 minus 2 gives you a negative 2. So there. So now we know where the y-intercept is, or excuse me, yes, where the y-intercept is. All right. Now, we know the graph's going to go down to the left, so I'm kind of thinking it looks like it'll go down, hit here, hit here, hit here, and come up, something like that. So the only way to know for sure, and we've talked about this, is to get some numbers. Sorry about that. Is to plot some numbers in between these zeros. For example, here's one of your x-intercepts, negative 1.4. Well, I'm going to look at my table of values very quickly, which I already have pulled up here, and I'm going to see. Hold on, just 1 second, please. I'm going to go to my table, and I'm going to see what the graph does at negative 3. Negative 3 is all the way down to 77. Negative 2 is all the way down to negative 14. So I'm pretty sure, I'm pretty good on saying this thing's going to shoot way down here, okay? And I know it's going to hit here. Now, what does the graph do at negative 1? Well, let's see. At negative 1, it goes up to 3. So I'm assuming the graph's going to come up, hit here, curve, hit this 0, then hit the y-intercept. Now, what does the graph do at positive 1? Well, if you look at your table of values, positive 1 is way down here at negative 5. So I know the graph's going to hit here, start curving up, and then comes through this x-intercept here, then on up. Okay, so not too bad. Now we can check for multiplicity real quick. There's really no need. There was no multiplicity to look for, so that was not necessary there. Okay, let's see if it makes sense. The degree is 3. The maximum number of zeros or x-intercepts I can have is 3, and I have 3. And also the maximum number of turns is 1 less than that, 2, and it took 2 turns, so everything looks good. Okay, number 97, we're finally finished. I'm going to start off by factoring this real quick. Pull out an x out of everything. First of all, pull out an x out of everything, and you're left with 2x cubed minus 3x squared minus 2x plus 3. So pull an x out of everything. Okay, then next, pull out what's common out of the first two here. That's going to be an x squared, leaving you with 2x minus 3. And then pull out a negative 1, and that should leave you with 2x minus 3. Okay? So the final factorization will be x, and then your matching parentheses, 2x minus 3, and then your other parentheses, x squared minus 1. Now we should know by now, men, that you can factor x squared minus 1. We really should know that. I mean, we know the square root of both of those numbers. The square root of x squared is x, and the square root of 1 is 1 and 1. Make one positive, make one negative. So I did go ahead and factor first. I know it's kind of going out of steps, but I just wanted to do that just to get that done. Now let's go ahead and get back to our normal steps here. Okay, first of all, let's go ahead and draw our coordinate plane. And here we go. Alright, I am still here, so please don't think that I've disappeared. Okay, here we go. Now, let's see. End behavior. End behavior. Well, it's a 4th degree, and it's a positive coefficient. Positive lead coefficient, so I know the graph is going to go up to the left and also up to the right. Okay, next, let's plot all of our x-intercepts on the x-axis. Well, if I took this group here and set it equal to 0, I would get a 0. If I set this group equal to 0, I'd get a positive 3/2 or a positive 1.5. If I set this group equal to 0, I'd get a negative 1. If I set this group equal to 0 here, I'd get a positive 1. So there, I found all of my x-intercepts pretty easily. Now your y-intercept, if you put a 0 in everywhere there's an x, you will get out just 0, so your y-intercept is also 0. Now it looks like to me the graph's supposed to go up, so I'm assuming it'll do something like come down, hit here, hit here, hit here, and then come up. I'm just assuming. I don't know that for sure, but that looks like a decent theory. Now, I'm looking at my calculator here. Just give me 1 second. All right. Now, what we're going to have to do is we're going to have to find these values between these x-intercepts and also to the left. For example, here's an x-intercept, -1. I would like to know what the graph is doing at -2 and -3. So I've already typed this equation into my grapher. I'm going to go to my table of values, and it looks like at -2 I have 42, and -3 216. So this thing's really shooting up quickly. So my theory so far is right. So the graph's going to hit here. And then I'm going to put in a -1/2 just to see how far it goes. And I'm getting a -1.5. So -1/2, which is in between these two zeros right here, is down -1.5. So that looks like it'll hit right there, curve, and start coming back up. Now, I am going to look at +1/2. I want to see what the graph is doing between 0 and +1. So I am going to put a +1/2 in. And we'll get 0.75. So we're over a half, and we're up 3 curves. Or 3/4, excuse me, 3/4. Now we hit this +1, and then the other 0 is going to be 1.5. I guess I could put in 1.25, which would be in between there. Probably not necessary. Yeah, I'm getting a -0.3, so it's barely going to go down. So we'll just say it hits here, curves, and then goes back up. If yours is not exactly like that, don't worry about that. Okay, that's totally fine. Now, the degree was 4, so the maximum number of zeros is 4, and we had 4. The maximum number of turns is 3, 1 less than 4, and we had 3 turns. So that's it. This is really good practice for you guys. Really, really good practice. And I know this video has been really long. However, there were no notes today. So hope this homework video has been a help to you. Call or email if you have any questions.